Hello, everyone. Welcome to Hope's class. Today, we will look at the concept of limit. At the end of the last video, we talked about using the average rate of change to approach the instantaneous rate of change. However, we left one unanswered question. What should we do when we get a 0 over 0? We have learned that the denominator cannot be 0, but we can let the denominator approach to 0. Approach. This is where we need to use the concept of limit. This is read as the limit of f(x) as x approach to a is equals to L. There are three criteria for the limit exist. We will talk about it later. Approach. How do we approach? Let's start with a simple question. Here is a number line. Think about number line close to 3. You may say 2. Good point. Someone else may say 2.9 or even 2.99. It's all correct. If we approach 3 from the left side, we call it the left-hand limit. Since these numbers are smaller than 3, we say the limit exists as x approaches 3 from the left. Similarly, we can approach 3 from the right side with a number like 4, 3.1, or even 3.01. We call it the right-hand limit. Since these numbers are greater than 3, we say the limit exists as x approaches 3 from the right. Okay, let's look at one example. Consider the function f(x), it is x squared. Evaluate the limit of f(x) as x approaches 2. We will use a table to help our understanding. When x approaches 2 from the left, for example, when x is 1.9, substituting into y equals to x squared yields the y value, it is 3.61. Repeat this for the x equals to 1.99 and x is 1.99. You will find out when x approaches 2 negative, the value of the f(x) approaches to 4 from its left. When the x approaches 2 from its right side, such as 2.1, 2.01, and 2.001, their corresponding y value is also approached to 4 from the right side. Here, we can check the three criteria for the limit exist. Both the left side and the right side limit exist, and they're equal. We conclude that the limit of f(x) it is x squared 4 when x approaches 2. Okay, next example. Consider the function f(x) it is 1 over x. Evaluate the limit as x approaches to 0. When x approaches 0 from its left, for example, try x equals to negative 0.1. Substituting into y equals to 1 over x yields the y value, it is negative 10. For x, it is negative 0.01 and x is negative 0.001. We get the y value like negative 100 and negative 1000. So when x approaches 0 negative, f(x) approaches negative infinity. When x approaches 0 from the right side, such as x it is 0.1, x it is 0.01, and 0.001, their corresponding y value is 10, 100, and 1000. So when x approaches 0 positive, f(x) approaches positive infinity. Here, let's check the criteria. Both the left side limit, right side limit exist, but they're not equal. So we conclude that f(x) it is 1 over x do not exist when x approaches 0. Okay, let's review. There are three conditions for limit exist. Number 1, the left-hand limit exists. Number 2, the right-hand limit exists. Number 3, the left-hand and the right-hand limit are equal. In the first example, all criteria has been satisfied, so limit exists. For the second example, the third condition fails, so the limit does not exist. In the next session, we will look at the more graphic example of limit. Thank you. For more information, please search Toronto Teacher Hope in YouTube.